Here in this video, we'd like to talk about molar specific heat of a gas at constant volume and at constant pressure. So first let me start our discussion by saying what is specific heat in general for a solid or a liquid is specific heat is defined as amount of heat required to raise the temperature of unit mass of substance by 1 degree centigrade. So when you say unit mass, you may be taking a gram or kilogram amount of heat required. So when you are talking about specific heat of solids or liquids, we need not worry about the effect of pressure. Pressure has no impact at all on the volume while you are talking about a specific heat. But when you are talking about gases, but for gases, first of all, you cannot take per unit mass, but you have to take per unit mole, because in measuring mass, in measuring gases, more standard way of measuring its content is mole rather than that of grams or kilograms. So for specific heat for the gases is defined per mole, not per unit mass. That's one thing. One more thing is, when you supply a heat energy, it's not only the temperature that's get affected, it's the pressure also that gets affected because of the supply of this heat energy and temperature in the case of gases. So, in the case of gases, when you vary the temperature with temperature, that is with heat energy, it is two parameters that varies, volume as well as pressure. Studying both of them parallelly is a bit difficult because we don't know who is varying by how much. That's why while we are defining the specific heat of the gases, we keep out of this volume and pressure one constant and study the other. Thus, gas has two kinds of uh, specific heats of gas. So, what we can say? Molar specific heat. When you say molar specific heat, you mean to say per mole of gas exists at constant volume. We keep volume constant, so we study the other parameters, right? And we also had it at a constant pressure. So let us define each of them separately. First, let me define molar specific heat of gas at constant volume. As it is kept at constant volume, it is called as CV. So CV is defined as amount of the heat required to raise the temperature of unit mole of, see, be careful. Earlier I said unit mass, but now I am saying unit mole of gas by 1 degree centigrade. So here what we have kept constant is at constant volume. As the volume is kept constant, change in the volume equal to 0. As per the first law of thermodynamics, total heat energy supplied to the system is change in internal energy and external work done by it. As I have derived, external work done by it can be written like PdV, where dV is change in volume. When you are talking about molar specific heat of the gas at constant volume, as volume is kept constant, change in the volume is equal to 0. That implies dQ is du plus P dV equal to 0. So in the place of dq in this equation, I can write du itself. It implies specific heat of gas, molar specific heat of gas at constant volume Cv is 1 by n. In the place of dq, I can write du by dt. That implies du equal to n into Cv into dt. So I want you to understand one thing carefully. When you keep the volume constant, there is no change in volume, thus work done equal to 0. The heat is required only to increase internal energy. We don't need to do any external work. So I wanted to just write here we need to supply heat for 1 mole of the gas only to increase its internal energy. No need of dW. That is Cv. Now let's talk about the another part. What's another part is molar specific heat of gas at constant pressure. It is called as Cp. So Cp is defined as amount of heat required to raise the temperature of unit mole of gas by 1 degree centigrade at constant pressure. Be careful, pressure is constant, change in the pressure is 0, but volume is not constant, so change in the volume is not 0. That implies, as for the first law of thermodynamics, dq, du plus dw is pdv. So neither this second part becomes 0 nor this first part becomes 0. So dq is dq itself. Therefore, Cp can be written like 1 by n dq by dt. That implies dq can be written like n into Cp into dt. I want you to understand one point very carefully here, that in the case of molar specific heat of gas at constant volume, we need to supply heat only to increase internal energy, no need of doing any external work. But in the case of molar specific heat of gas at constant pressure, we need to supply heat energy not only to increase internal energy, but also to do external work. So it's very clear to you by this time that we need to supply more heat to raise the temperature of unit mole of gas by 1 degree centigrade in the case of Cp than Cv, because in the case of Cp, we need to supply the heat energy not only to increase internal energy but also to do some external work. Whereas in the case of Cv, we need to supply the heat energy only to do increase in internal energy but no need of doing any external work because volume is kept constant there. So it's obvious that dq demands more heat in the case of Cp than Cv. That's the reason why Cp is greater than Cv. Of course, the ratio of Cp by Cv is called gamma, ratio of specific heats. We'll talk about that in another video, right? But as of now, I need to tell you once again that Cp is greater than Cv simply because in the case of Cp, we need a dq to increase internal energy as well as to do external work. Whereas in the case of Cv, we need to supply heat energy, only to do increase internal energy and no need of doing any external work. That's it. Thank you for watching.